Deploying operating systems. Let me ask you a question. So you've obviously played with Ghost before, right? You're familiar with this tool, Ghost. I mean, heck, who hasn't? If you've been in the IT world for any period of time, at least sit down with Ghosts a few times, if not a lot of times, to use this to image one computer system to another. You know, Ghost was a great tool for a lot of years. In fact, my own personal career, I got my first big success thanks to Ghost. Back in that day, people were still building computers by hand, and I remember coming into this new job, and I made a bet with the chief scientist at the company I was working with. At the time, it was taking them forever. They were building like one computer a day, maybe two computers a day, and they had a big project coming up. I said, look, I'll make you a bet that I can build 300 computers in a month. And if I do, you'll make me a systems admin. And, well, not much time passed before we were able to build not only 300, but quite a bit more than 300 machines in a month. You know, Ghost really changed the whole landscape of how we deploy operating systems. But let me tell you what, it's time to put Ghost to bed. The whole concept of Ghost, the entire notion surrounding Ghost, and the monolithic approach that Ghost uses to get one image sent over to another image is these days, well, it's just not really recognized as being a workable solution. Interestingly enough, Ghost is one of those technologies that actually gets harder to use the longer you use it. And I'll show you, in fact, it was not long ago, let me minimize this here, that I actually wrote an article for TechNet Magazine. I've read a column for TechNet Magazine there called The Geek of All Trades. And a couple of years ago, I wrote this article called A Case for the Layered Approach to Deploying Windows Desktops. And the article is fairly interesting, but the thesis of the article is based around this image. Now, in the Ghost world, right, the Ghost deployment concept focuses exclusively on kind of this monolithic approach where I'm not really interested in all these individual layers, but I'm interested in deploying just a Ghost image, right? Some kind of GHO file. Well, that monolithic image, it's great if the computer you're deploying to is exactly the same as the computer you're deploying from. And it's great if nothing ever changes in your environment. We all know that's not the case. And so replacing Ghost is perhaps a much better solution that involves working with each of the individual layers inside of the Windows operating system and using the tools that make sense for those layers. So, you know, we can kind of skip this one down here at the bottom. But for core operating system and even for the drivers, we have tools like Windows Deployment Services and the Microsoft Deployment Toolkit, and as you'll find out, Configuration Manager, for squirting down that core operating system and then getting the drivers on top of it. In fact, leveraging plug and play, the whole plug and play infrastructure, you can have these days just a nice little database of drivers that sits out somewhere that as long as the operating system installation has access to the database, it can then query for the unique identifiers for all the hardware and then just grab all the drivers right out of that database and insert them during the installation. We don't have to worry about drivers anymore. If I have, for example, a WSUS infrastructure in place, well, then I can inject OS updates over the top of that image right at the install. If I have an application infrastructure in place, I can inject those applications as well. If I have some sort of solution like group policy or preferences, or as you're going to find out here in just a minute, compliance settings. You can even set down specific configuration changes. Gosh, with a tool like the User State Migration Toolkit, I can even squirt down that user's personality. I can suck it off of the old machine and then redeposit it back down onto that new machine. So the layered approach, and you'll notice that none of these actually refer to Configuration Manager here, but the layered approach here is in many ways a superior way really for a lot of different reasons. One is that at any point, so let's say my drivers change. Changing that driver requires modifying just the contents of that layer. Changing an application loadout on a machine or on my golden image requires just clicking a couple of buttons to add that application into the next time we end up imaging a computer. So this layered approach presents a much more manageable, much more over time, kind of life cycle manageable, a way that you can essentially deploy operating systems down to the different machines in your environment. Laptops, desktops, doesn't matter what kind of machine it is. With the whole notion, the whole guiding idea of single image deployment really can become a reality if you approach OS deployment using this layered approach. So that's really, this introduction really helps us kind of come to grips with the notion that Ghost was a great tool maybe back in the past, but Ghost's time has come and gone. And replacing that is now a new and much more fully featured solution like Configuration Manager, like even some of the free tools if you didn't have Config Manager. But these tools that allow us to create that layered approach towards deploying Windows images. Now I'll tell you, Config Manager actually wraps around the concepts of Windows Deployment Services and also the Microsoft Deployment Toolkit. If you are familiar with WDS, if you have a familiarity with the Microsoft Deployment Toolkit, well then deploying operating systems using Config Manager is going to be a piece of cake. In fact, most of the screens look almost the same. The entire process you go through looks relatively the same. So those technologies are kind of almost foundational towards understanding what we're doing here in Config Manager. So with that, I want you to take a look at that website. A number of years ago, I got irritated with some of the ways that certain members of the deployment community were trying to advertise how we should go about teaching people to deploy Windows. And that approach kind of started with the most difficult processes first. You can't really understand how Config Manager deploys stuff until you really kind of understand WDS and then MDT and then you add in all these additional layers of new technology. So out of frustration, I went and wrote a book called it's actually right here, called Automating Windows 7 Installation for Desktop and VDI Environments. And then I gave it away for free. This book, which you can download from this website up here at nexus.realtimepublishers.com, is 8 chapters long. The first 7 chapters are really only the ones you need to for this sort of deployment. And you can literally just download it. You'll need to punch in your email address, but there's no cost for this book. And I point people to this book constantly because it presents all of the foundations, all of the basic sort of underpinnings and technologies that you need to understand if you're really going to come to grips with how Config Manager ends up deploying operating systems. And I say that because there's a lot of tech here. I could spend nuggets after nuggets after nuggets talking about all the different stuff that has to get laid into place for this to function, but I'm not going to do that. Because if you do your background study, and if you come to understand what WDS or how WDS participates in OS deployment and how the pieces of MDT also participate in Config Manager's approach to deployment, well, you're really going to do better in terms of understanding this deeply as opposed to just at the surface. Now in this nugget, what we're going to do, we're going to spend some time actually preparing Config Manager for OS deployment. You'll find that there are actually a number of different tasks that you have to do more or less in order so that a right out of the box Config Manager installation can have all the things that it needs. You got to have the drivers. You got to have the OS images. You got to have the applications. You got to have boot images. You have to have the Pixie infrastructure if you're doing those kinds of deployments. So that's actually a fairly sizable portion of this in terms of the click by click because there's just a lot of stuff that has to happen. Then with that, we're going to go and capture an OS image. So this capture process is kind of interesting in the way that Config Manager does it as opposed to WDS or MDT. And if I can draw this little picture here, so here's one computer, this is your computer that you're going to deploy to, and here's your Config Manager server. The process goes a bit like this. In creating an image, or creating an image for capture, what Config Manager intends to do is to automate the entire process of creating even your golden image. And that's important, right? Because you want to be able to create a golden image that's got all the stuff baked in it so that you can deploy that out later on with good performance. And so what Config Manager can do is actually deploy the image to a computer, just a sample computer, and then once the image is deployed, then gather the image back off to create the image that will later deploy to other computers. That's why it's called a build and capture image, because you build the computer and then you capture it back to Config Manager. That takes, the reasons why that has to happen are going to take you a while, but they actually make sense once you finally sort things out. It's a good idea because this whole process creates an automation that allows you to then insert different settings at different layers in the stack just to create a different image. You don't want WinZip today. You want 7-zip. Well, all right, let's remove the WinZip and add the 7-zip. Bam, we're good to go. That is the capture process. Once we have the image, once the image is captured off of that machine, well, then the next step is the deployment process, actually deploying an OS image out to the different computers in our environment. So that's what we're going to do in this nugget. And I understand that this is a fairly lengthy introduction to that process, but you kind of have to understand why Config Manager behaves in the way that it does for any of this next click by click to actually make sense. So, okay, I've got my Config Manager server here. You'll notice that I'm taking a look under Software Library at Operating Systems, and I've got the 6 different nodes here that correspond to OS deployment. We're going to create drivers and packages and OS images and OS installers and boot, well, actually boot images exist on here out of the box, and ultimately task sequences. But there are a couple of things we have to do first. The first of these is to actually go here to our sites. And here in our sites, what we're going to do is go to the site component and to the software distribution component. Now, we've been here before. I told you that this network access account is the account that's used during software deployment so that there's some sort of credentials that deployment can ultimately get to resources around in your network. Well, in the case of deploying applications, using local system, the computer account of the Configuration Manager client is going to work just fine. But because we're deploying operating systems, we're going to be working kind of outside the normal scope of what we think of as Config Manager. We actually have to specify an account that can access those network locations. Here's our SMS client install account. Okay, right now this has a, I believe this is a domain controller. But this client install has to have enough privileges so that it can get from that machine that we're going to deploy to back into the Config Manager infrastructure, back onto the shares so it can download all the OS stuff that it needs. So I'm going to set that as our account here because, well, I have to. Once we set up that software distribution component, there are a couple of additional roles that we need to add to the site server that we have. We're going to right-click here on Config Manager 1 and add 2 site system roles to this computer. The first is going to be the state migration point. Well, actually 1, I should say, because we're going to modify another role. This state migration point is what's used by the User State Migration Toolkit as essentially a file share for storing information, storing user data on some sort of computer when we're doing a refresh of that computer. Now I'm going to create a folder here, just a simple storage folder, and I'm going to call it C:\source files. And I'm only doing this because I already have the shares set up. You would probably create a different location. This will enable, let's see, 100 clients, and I can set a minimum free space of 100 megabytes. This storage folder is really a temporary storage folder location because when later on I have an existing computer that has an existing user and all of their desktop shortcuts, their MP3 files, and their pictures of their kids, when those need to get automatically removed from that computer so that I can rebuild the computer, and then that gives me the ability to re-inject all that content back onto the computer again. So it's only there for that short period of time between when I take things off, rebuild the computer, and put stuff back on. You'll see I can have a deletion policy here. Do I want to delete it immediately, or do I want to give it an extra day just in case? If you can think about it, and sometimes these deployments may actually incur an issue. And you don't want to delete the person's content because, well, by deleting it, I have no backup plan. So setting this to 1 day gives you that one little extra bit of caution, and it also makes sure that the user's data ends up on at least 1 backups taped so that you can restore that if you need. If this state migration point is going to operate in restore only mode, you can set that as well. Now we're going to use this to both store and restore. So we are going to create this state migration point. Now, this state migration point, as you can imagine, is going to have to upload and download a pretty sizable amount of content. Have you ever taken a look at a user's profile and they've had all of their, again, MP3s and photos and files they should have on the file server and whatnot? You know that, well, those can get relatively big. So we want to make sure that we set that to a local boundary group for this state migration point so that we're not actually failing over to some location way out in the ether. Choose next, next again, and that actually creates that state migration point. Okay, again, this is a temporary storage location for the purposes of migrating user data off and on the computer. Okay, count of roles is equal to 12. That share has been created. The next step we have to do is modify one of the other site system roles, and that's the distribution point here. So the DP, by default, is set up just as a standard distribution point. You know, it's typically bits enabled, but more often than not, we just use it as a location for the clients to go and grab their application data that they would need. What we haven't done is actually enabled Pixie support for clients or a multicast support for clients. Now I'm going to enable multicast here, but I'll tell you, in your environment, the odds are that you will be able to use multicast in your world are fairly slim. Most network individuals, or most network admins, are not real keen on enabling multicast throughout an environment because it tends to just bring the network to its knees. So I'm going to turn both of these on, but be aware that you'll probably be using Pixie, but probably not multicast. Now when I turn on Pixie, there are a couple of requirements that we have to be aware of. One of which is, well, that there are some ports that are being used and that we need to make sure that the firewall is open to support those ports. The other has to do with DHCP. In most of our environments, the Pixie service point, the distribution point, is not on a DHCP server. But if it is, DHCP and Pixie can use the same port. So there's some extra work that's required. There are 8,000 different knowledge base articles that explain this problem. But be aware that as long as you've got Pixie service point on one computer, DHCP on another, you're going to be fairly good for at least for this phase of the game. Now, do you want to allow this distribution point to respond to incoming Pixie requests? So when a user actually hits the F12 and Pixie boots, do you want this computer to respond? And do you want to enable unknown computer support? So with unknown computer support, when a client comes in and that client has a MAC address that the config manager is not aware of, it's never seen this machine before, it doesn't know who this computer is, well, turning on unknown computer support allows me to have config manager run any required task sequences on those computers. This can be useful because, well, if I have machines that are just coming right off the dock and I've brought them out of the box and I want to get them uploaded with a new OS, well, I just want to be able to power them on with a network cable plugged in and hit F12 to get an operating system deployed onto them. They're unknown when they come out of the box, so I have to have unknown computer support on in order to support all these. Now you'll notice that there's a couple other things in here. Required task sequences include operations such as apply operating system image and format and partition disk. The idea here being that in order for unknown computer support to work, well, we've got to format the disks and we've got to actually apply an operating system for these. I'm not actually going to turn on password just to make things easy. And for now, we're not going to use user device affinity. User device affinity in this case would allow me to use that same affinity I was using for applications for the purposes of deploying operating systems out to these computers. Now for Pixie, I can choose if I'm going to respond on all network interfaces or if I have specific network interfaces I'm going to respond on. Again, if I'm maybe doing multicast, for example, I may have a specific set of interfaces I just want to use for the purposes of multicast. Or if I have different interfaces that I want to segregate off traffic for other reasons, I can do so. Over on the multicast side, turning on multicast allows me to either use the computer account of the DP to connect to the database, and I can choose an IP of whatever IPv4 address range I'm looking for multicast. And then again, just some specific settings here associated with doing this. I'm not getting in much detail here because for most of us, again, multicast is really not an option in our environments. But what that does is that sets up this config manager server as a machine that's going to be listening for those Pixie requests as machines attempt to boot to the network. Now the notion here is that when those machines boot, they're going to boot to the network. They're going to attempt to find that Pixie server, communicate with that Pixie server, TFTP to it to download a bootstrap file, and then ultimately communicate back with that server to get some sort of boot operating system that we can use for deploying Windows. Now, if you've if you've paused this and gone through all of the background homework, you already understand that that boot operating system, or that that pre-OS, is WinPE, or the Windows pre-installation environment. And in fact, here inside of Configuration Manager, there are two boot images that have already been created: a boot image for x64, and a boot image for x86. So WinPE, and I'll direct you to the background information for more details about WinPE. But WinPE is a very light version of Windows that's designed for really no other purpose than to get a network stack up and operational so that that OS can communicate with some other computer out in the world to download an install image to the computer for the purposes of installing the computer. So what we're doing, at least up until this point, is creating all of the infrastructure that's required to get that booting process to occur. For our next step, we have to start working with the images that we ultimately intend to deploy. Now, we're going to work here for just a little bit with these 6 items here under operating systems. The very first item we want to import in is an operating system image. And before I actually show you this operating system image, I want you to know that down here in the location we've been working with, the SMS source files location, I've actually brought in a couple of different items, just so you didn't have to see the process of bringing them into source files. So what's there? The first of which is drivers. And you'll see here that I have the VMware iSCSI driver that I've actually just sort of extracted out of VMware Workstation's windows.iso file. If you look inside of VMware Workstation, the VMware Tools actually mounts an ISO file with a big setup. And that setup installs all the drivers that are necessary to make a VMware Workstation VM work inside. And so what I've done is just extracted out these drivers, specifically because when we actually go to import in these drivers, we're going to need them in their raw format here. Notice the INF and the CAT and the OEM file. This is the most basic raw format that these drivers ultimately exist in. And as we move on in just a minute to start talking about drivers, the entire suite of drivers that you have for your different desktops you intend to deploy to, one of the very first things you're going to need to do is actually extract those. WinZip or 7-zip is typically very handy in doing this, down into their most constituent components. In addition to that, I also have a copy of Windows 7 Service Pack 1. This is just straight off the DVD. Okay, there's the setup file if I wanted to install Windows 7 Service Pack 1. Now, what the experienced deployment person recognizes, but perhaps the non-experienced person doesn't, is that the actual meat in the Windows 7, or really any Windows deployment, actually happens in a file called a WIM file. And the WIM file that's important here is one called install.wim. That WIM file contains the real meat behind the installation. It is what we're going to point to here in just a second as the OS image. There actually is another WIM file on there too I should show you called boot.wim, which contains the contents of that WinPE image. Now we're not going to deal with this specific boot.wim because there's a very different boot.wim that Configuration Manager needs to use to support all of its built-in automations. But I just want to make you aware that this is what's found here inside of this Windows 7 Service Pack 1 location. I've also made a copy of the USMT tools here in this location. So we have to actually, and we'll do this here in just a minute, create a USMT package for purposes of having, well, of sucking off all that user state stuff and later deploying it back down onto the computer. We'll do that here in just a second. That USMT data can be found directly on the system if you go into the C drive, and I believe if you go to Program Files and Windows AIK Tools USMT. So I just copied that over to the source files location to make things easy for us at this point. So back here in the Configuration Manager console, there are a couple things we have to do. The first is to identify which operating system image that we want to ingest into this Config Manager server. If I right-click and choose Add Operating System Image, I'm looking for the WIM file that's associated with the image I want to eventually deploy. And the WIM file I'm looking for at this point is the WIM file that's directly off of the Windows 7 DVD media. It's the most core, most basic Windows 7 deployment image that I could possibly find. Because again, based off of that layered approach, I want to layer things on top of it as opposed to having one big monolithic image. So here what I want to do is connect up here to Config Manager 1, Source Files, Windows 7 SP1, and then sources again because I'm looking for install.wim. That install.wim should be found on was essentially any of the DVD media that you have. So let's connect up here to install.wim, choose next. This is Windows 7 Enterprise, and I believe it's actually SP1 even. Choose next again, and next to complete adding in that operating system image. Now, in addition to the OS image, we also have to have an OS installer. That OS installer is actually found at the root of the DVD. So if I go over here to OS installers and right-click to add an operating system installer, the next thing I have to do is go to // config-mgr1 source files, and in this case what I'm looking for is Windows 7 SP1. If I've got everything right, it'll allow me to continue. This is Windows 7 SP1. I can add a version and content information in there if I want also. But really all I'm doing is making the pointer that I need to add this operating system installer into my config manager installation. Now you might have desktops where the drivers for those desktops are completely represented on that Windows DVD media. And that's fine. Lucky you, in fact. But for most of us, the drivers that we need are found on the websites of whatever manufacturer is creating our hardware. And so we have to have our own custom drivers that we add in. As I told you before, this whole concept of there being this kind of global driver database that an image that is being installed can point to ultimately grab whatever drivers it needs. Leveraging plug and play, as long as I create drivers here, well, then I can make those drivers available for deployment to an image using that whole plug and play infrastructure, greatly simplifying the process of having to deal with all the drivers that I have. Now what's interesting is that here in this location, if you've already gone through the process of unpacking all the drivers, as I told you just earlier, into their disparate components, it's my guess that you probably have somewhere on an IT file share somewhere a subdirectory that contains all the drivers for all the different equipment you're responsible for managing. Notice right here, import all drivers in the following network path. Now what it doesn't tell you is that when you select this top selection, it will actually import in all the drivers from that path and all subdirectories of this location. So if you have your IT file share, again mine's back on config-mgr1 in the source files location, but yours might be somewhere else. If you have those drivers, well, you can simply just connect up to that driver's location and, well, poof, it will go and ingest in all of the drivers that it finds as long as they're unpacked into those disparate components. This makes things really, really easy because most of us have a little driver share for all of our equipment sitting around in some location. Now, as you can imagine, there are a lot of different drivers out there, and sometimes matching the right drivers to the right pieces of hardware is something that plug and play gets a bit confused about. For that reason, we have the ability to create categories for these drivers. Now, down here in the bottom, you'll notice that there's an option for duplicate drivers. We don't want to import in duplicate drivers here. We can, however, import in duplicate drivers and do various things with it, like create new categories or keep existing categories. But in this case, I'm not going to import in the duplicate drivers. These categories are what allow me to create, for example, one category for my Dell desktops, and one category for my HP desktops, and one category for my x64 stuff. And however I want to divide these things up, because to make them logically collected for the purposes of later distribution. Now you'll notice that here when I actually scanned that location, I found the VMware iSCSI driver, and there's that txtsetup.oem. I want to enable the driver and allow computers to install it and actually set up one or more categories here for that driver. Let's call this VMware Workstation, because this is a driver that allows VMware Workstation enabled VMs to run specifically their iSCSI. So click OK here, and OK again, and next. Once I have a driver, the next step is to actually add that driver into what we think of as a driver package. And the driver package is what gets uploaded up to the distribution points so that computers can ultimately use them. Now, this is a somewhat complicated or confusing screen because you actually have to go down here to select New Package to actually create the package that will get uploaded into your distribution points. Let's call this VMware Workstation Drivers. And the path that I'm going to use is, again, config-mgr1. 1, source files, and instead of drivers, I'm going to choose drivers and driver packages. Select that folder, choose OK, and you'll see that I'm now going to upload those VMware Workstation drivers, a package containing them, to that location, and then also update the distribution points with that content once I'm finished. Choose Next. At this point, I have some options that I have to pay very particular care with. So I told you that when you're deploying an operating system that there's this nice rich plug-and-play infrastructure that can go and look at all the drivers that exist in a connected database and extract out the ones that make sense for whatever it has available. But I also told you that there's this special light version of Windows that's used as the pre-installation environment for installing Windows. Well, that very light version of Windows doesn't have all the driver support and all the nice plug-and-play features that the real version of Windows actually has. And so if there is a driver that is required not to run Windows, but to boot the Windows PE portion, well, I need to actually inject that driver into the boot image. You'll notice there are two boot images here, x64 and x86. If I have a driver, or I should say, if I attempt to boot to WinPE, and the boot fails because it can't get whatever resources, or it can't find a driver for whatever hardware exists on that computer, I'm going to have to actually import in that driver to support it inside of WinPE. Now here's a big caution for you, very big caution for you. Before you ever import any drivers into these boot images, take a copy of these boot images and put them out in some location for safekeeping. It is just a known, at least historical issue with this WinPE driver injection, that while the injection of drivers tends to work fairly well, the later removal of drivers is sometimes very challenging or sometimes doesn't work very well. So if you ever find that you have a WinPE, or that you've injected a bad driver into a WinPE boot image, it's generally a good idea to start with the clean, right out of the box boot image as opposed to trying to pull drivers back out. It's just kind of a good idea all the way around. Now, I'm not actually going to update my boot images here. I am going to update those distribution points, however. Actually, this update distribution points would be with the boot images, so I don't necessarily need to. Choose Next again, and Next. And as you'll see, we're now importing in those drivers here into the database and creating the packages that need to be uploaded up to those distribution points. So this is that whole process of inventorying, sucking in the drivers up here, and then ultimately creating a driver package that then sends the content out to the distribution points. We're getting pretty close here. We're actually getting quite a bit of this process really well set up, but we're still not done yet. There are two very important packages that we have to ensure actually get injected into an image so that we can support all of the things that we need out of that image. One of which is USMT. Right? If I want to be able to upload all of that user content, well, I've got to have a USMT package that's been created so that that package can get incorporated in the task sequence we're about to actually create. The other thing I have to have is a config manager client package. In order for this infrastructure, or these machines that I've deployed out using this infrastructure, to then return back and become a part of the infrastructure once the installation is complete, well, I have to inject down a client package, or the agent onto these computers, so that once they're done, well, they can talk back to the config manager infrastructure. What's good about this, at least one of these has already been created. In fact, if I go here to Packages, you'll see the Configuration Manager client package that we already created because we had to deploy out that client package before. What we don't yet have is a USMT package. And so what we need to create actually is a package that actually has no program. We'll call this USMT. What we're looking for is a USMT package that indeed contains source files. And in fact, just like before, I've already copied those MGR1. I've copied those to the source files location here. And under USMT, I've got my AMD 64, and that's the folder I'm looking for. That package, well, that package contains all the stuff that ultimately needs to be wrapped up to create the package that'll be used by the OS Deployment Toolkit. So I'm going to create the package. I am not going to create a program because the program is actually handled by the OSD portion. Choose Next, and Next again, and my USMT package is now complete. So at this point, what do we have? we have the infrastructure in place, we have an OS image, we have the OS installation media or the installer, we have the drivers, we have driver packages, we have the config manager client, and we have the USMT package. So at this point, we probably are getting really close to being able to deploy that operating system. I do want to spend 1 minute here before we go about that to show you some of the properties that are associated with the boot image. Many of these you probably won't be adjusting too much, but you should be aware that they exist here inside of that boot image. Now, as I told you, Windows PE is this little micro version of Windows, and so consequently it's possible for you to use other tools outside of Config Manager to adjust some of the configuration of that boot image. If you do, however, you'll notice that you'll have to click the reload button here to make those changes part of your Config Manager infrastructure again. There are a whole bunch of tools out there, ImageX and various other tools that have changed names from over the years that can be used for adjusting some of the properties of these images. Here are the drivers that may or may not be in there. I can add additional drivers here by selecting them if I wish. There are some customization items in here for pre-start commands. I can change the default background if I want. This item down here at the bottom marked Enable Command Support is particularly handy when I'm just setting up this infrastructure. When I don't have this box checked, there's no way for me to break through the actual automation to figure out what's going on or to view log files. So by selecting this Enable Command Support, I can hit, I believe, the F8 button during the process of any kind of boot or image deployment or image capture to bring up a command prompt window that allows me to view log files or to make changes to that Windows operating system. Here's the data source. You'll notice that a WIM can actually contain more than one image. That's actually one of the features of the WIM format that Microsoft uses. I can choose to update the classic distribution point stuff, update them on a schedule, persist it in the client cache, deploy this image from the Pixie service point if I want. In fact, I will do that in order to support what I need to do here in just a minute. Data access, same data access items here, same distribution point settings here that we were working with before, same content location settings here, and then some security items as well. So these are, oops, I need to update the distribution points, yes. So these are the steps that we've worked with here to get this boot image up and operational. Now the next step that's required actually involves creating this build and capture task sequence that will later deploy out to some computer sitting out in our environment. And again, this is an optional step. You could actually create your own golden image manually. Build it with an operating system, install all the applications, do all the configurations. As long as that operating system exists in a work group and not in a domain, well, then all the rest will get handled by Configuration Manager. But the notion behind this build and capture task sequence is that it allows you to completely automate the generation of your golden image. It sets down the image. It sets down all the applications that should be on that image. And then it recaptures that image back up to create what your new golden image will be. Down here to task sequences is where all this happens. And in fact, if I right-click and choose to create a new task sequence, you'll notice that there are 3 different types of task sequences that exist. The first is your classic deployment task sequence. I'm going to install an OS image onto a piece of hardware. And that task sequence supports the refresh scenario, that supports the new computer scenario. That's any time I want to install an existing image package. The third one down here is a custom task sequence, which you won't find yourself using too terribly often until you get fairly advanced and fairly experienced with the whole process of creating these task sequences. For now, what we're going to use is a build and capture a reference operating system image task sequence. Doing so gives us a fairly large number of settings that we have to put together for doing this. Let's give this a name, build and capture. We want to select a boot image here, which we'll select the x64 boot image. I'm going to choose Next. We're going to install Windows. So to install Windows, I have to have an operating system image. That operating system image is here, Windows 7 SP1. I can choose which edition of Windows I want to deploy. If there are multiple images or multiple editions in that single WIM file, I can deploy or choose them here. I can select a product key if I want, or a server licensing mode. I'm deploying Windows 7, so there is no server licensing mode. And I'm going to avoid putting in a product key here at this point. I can select the local administrator password if I want. I'll set that to my usual local administrator password. I can configure the network. In this case, I want to join a work group. Because I'm doing a build and capture that, again, needs to be a part of a work group. Choose Next. I have to install the Configuration Manager client. I have that package already here, the Configuration Manager client package that we created, well, right when we installed the operating system. You'll notice that it's automatically populating the failback status point with config mgr1. I could add in here if I wanted to. I could add in the management point. I can add in other characteristics that I want to add into the client package here at this point. I'm going to choose Next to skip past that, and that will take me to the selection as to whether or not I want to include updates with this deployment. There we go. Now, right now we don't have any updates that we've actually configured. Where the update nugget comes up next. So I don't have an update infrastructure yet to install, so at this point I'm not going to choose to install any software updates. Once I have that update infrastructure in place, well, I can later go back and change the task sequence to interface with my update infrastructure so that I ensure I get all the updates that I need. Choose Next again. Now I have the ability to install certain applications. Now is where you can begin to see some of the real cool power that you can have by creating this build and then capture task sequence to create your golden image. So creating that layering, well, it's a good idea because I can then use all of the different pieces, all the different components of Microsoft to deploy at each layer. But sometimes they can take a lot of time. If I have a lot of different applications that I need to deploy, well, maybe it makes sense for me to have certain applications already available directly on the image. For example, the WinZip application that we created earlier. Now, one thing you have to be aware of is that these applications have to be made available whenever you're creating the application so that they can be supported inside of a task sequence. When we created that image earlier back on that last nugget, we didn't actually enable it for use here inside of the task sequence, so you're not going to see it here in this view. So for now, let's actually leave WinZip off of this task sequence. You'll notice that now, if an application installation ends up failing, well, we don't necessarily have to fail the entire image deployment. If I check this box here, if an application installation fails, go ahead and continue installing the other applications in the list. This can come in handy if you have certain applications that for some reason don't like to be installed in the order that they end up being installed in. Choose Next again. And that takes us to the system preparation item. Now, there are certain operating systems like Windows XP that have a specific configuration manager package that are required for system preparation, the sysprep package. In Windows 7 and also in Windows Vista, sysprep is actually built directly into the operating system. And so there's no separate package that's required for deploying operating systems later than really Windows XP. So we're not going to have to do anything here in this node. We can give some image properties if we want. And then also the capture image settings, or where we actually want to deploy this capture image. I'm going to put this up here under Browse, and then back here in my source files location, I'm going to create a new folder called W7SP1 Golden Image. There. And in there we'll just call this W7SP1-golden.wim. I have to use an account, specify an account that's used to access the output folder here. If I choose Browse, I can use that SMS account that we were using before, the SMS client install account, because that account has enough of the properties or enough of the rights and privileges that it needs to access this location. Let me punch in my password correctly here. Choose OK, Next, and finally Next. And that goes through creating that task sequence. So you'll notice there's not much really that happened in creating the task sequence. Because remember, this task sequence is just the metadata or the instructions that are going to tell this whole workflow what to do when it becomes time to actually deploy out, build, and then capture that operating system. If I right click here under Build and Capture, and you'll notice if I choose Properties, I have relatively just not that much here that I can take a look at. I can change some of the progress notification text if I want. There are a couple of advanced items here, but these are your typical items that are associated with the deployment more so than anything. What I do want to take a look at here is not the properties, but in fact the edit node here. This is the real meat and potatoes of an OS deployment. And these task sequences have gotten much simpler over the years. In fact, if you look at an MDT task sequence, it's quite a bit more complex than what you would see here. And even this is slightly different than what you'd see in older versions of Config Manager. What this task sequence does is it's very much like a run book. It goes through step by step, starting at the top and working its way down to accomplish each of the tasks that's required in the sequence. So restart in Windows PE is one of the first items. We partition the disk. We format the disk. We apply an operating system, which is this operating system here. We apply any Windows settings, those that we configured. We apply network settings. We apply device drivers. In fact, up here in the network settings, note your DHCP settings are set by default. We apply device drivers here if we have any device drivers. We're not actually doing so at this point. We can then set up Windows and configuration with any of these and Configuration Manager, the client, with any of these settings down here at the bottom. And then once all of those steps are complete, well, then we can go through and then capture that reference machine. We begin by preparing the machine, essentially going through the sysprep process. Actually, this is the sysprep process here, the prepare OS process. And then lastly, we go through the capture process for capturing that computer back here to this machine. Now, what a lot of people don't really recognize is that this build and capture task sequence is where you can insert in a lot of your additional automations that you may want to be on your golden image. So if I wanted to, here under the Setup Windows and Config Manager item, I can add additional items if I wish to create other automations that'll happen as part of the golden image creation. So maybe I want to install some application. It's under here, install application, or an update, or install a package. I can do some other things with disks, such as enable BitLocker. I can do things with the user state, like request user state or capture user state, although you'll see those a little bit later on whenever we go about deploying an actual image that we have. I can do things with the images themselves, applying another operating system image, or even a data image. I can change drivers or adjust some of the settings that are in there. So this gives you the ability, again, to customize everything about what you're doing when you're creating that golden image that you'll ultimately deploy out to the different computers in your network. For us to complete this process, just like anything else, we've got a couple of steps. The first is to distribute the content. Make sure that we get that content up on the various distribution points. Let's add those up to our Config Manager 1 distribution point here. Once we're done with that, the last thing we have to do really is deploy this operating system image, or deploy this task sequence. Deploying a task sequence happens in pretty much just like how you would deploy an application. We select the task sequence. We define which collection we want to send this task sequence to. Now note here, when we're defining out specifically the build and capture task sequence, I'm going to build and capture this out to a machine that Config Manager has no idea what this computer is. Because I'm going to use Pixie to boot this computer up, and it's never seen this computer. There's no Config Manager agent on there. It's unknown to Config Manager. So I need to deploy this build and capture out to all unknown computers, because those are the computers that are going to need to receive the image distribution so that they can begin the process of installing and then ultimately sending all the data back up to Config Manager. Choose Next again. I'm going to make this a required distribution. I'm going to make it available to Boot Media and Pixie. I'm going to make this deployment available essentially right now and set the assignment for as soon as possible. I'm going to rerun if there's a failed attempt. I'm going to allow, let's see here, I'm going to allow items to occur outside of maintenance windows. I don't care about internet-based clients. I'm going to not choose any alerts here. I'm going to download the content locally when it's needed by the running task sequence. Remember, in the case of very large packages, it's really a good idea to download that content first before beginning any kind of installation. Choose Next again, Next, and Close. And with that, we're ready to begin deploying out this image and going through the deploy and capture process that we've been setting up here through this whole period of time. So what's next is to have some sort of computer that's going to boot to the network It's going to talk to DHCP. Then once it talks to DHCP, it's going to grab its bootstrap file via TFTP from the Pixie server. Then with that, it'll actually boot into Windows PE and begin the image installation and capture. I actually have a empty virtual machine right here that we can use in order to do this. This is a machine, I've called it Capture W7 SB1 image, 2 gigs of RAM, 1 processor, 60 gig hard disk. And what this is going to do is, as I said, boot off the network, contact that DHCP server, contact Pixie, and eventually get in touch with Configuration Manager. Now I'm explaining this to you because this process happens relatively quickly as we watch it here on the screen. And if you've configured everything correctly, well, then this process should go relatively smoothly, and you should end up inside of Windows PE. Here in a second, we'll see the Configuration Manager screen that'll alert us that we're just about ready to start running that task sequence. But there are a lot of steps in this handoff that have to happen correctly if you're to actually make it this far. You have to have DHCP configured correctly. You have to have that Pixie service point up and configured correctly. You actually have to have a couple of special settings in with your boot images. Specifically, both boot images have to be available on that Windows deployment services, on the distribution point, for it to function. And I tell you all of this because there are a number of very strange error messages that you can receive throughout this process, and they can come from anywhere, because you have multiple different steps along this process and multiple different services that are handling all of the different orchestration to get you this far. Some error messages may come from DHCP, others from Pixie, others from Configuration Manager. One way that is usually really good at troubleshooting this process, if for some reason you don't get this task sequence warning, you're not about to run this task sequence, and you need to figure out why you're having a problem, is the use of the F8 command. Now, if you recall, back when we were creating the boot image here, we actually checked that box to enable this F8 command prompt window that'll allow us to take a look inside this client as it is going about doing its build. And specifically, the place you're looking for to find all the information is going to be found actually here, or actually not quite here, here in the root of the X drive, in a folder called SMSTS. And in fact, I believe it's smsts.log is the log file that you're going to be looking for. That log file, once we begin this process, and the process actually has some stuff to report on, should provide some very detailed information for you that'll help you kind of trace down exactly why you're having an issue with the distribution of this operating system image. In fact, if I just click back here one second time and go back to the root, let's see if we got that information here just yet. And yes, there we go. SMSTS log actually is the name of this place. So if I go to the SMSTS log folder, in a subfolder of that will be the smsts.log file. And Notepad is now available in Windows PE, so I can do Notepad smsts.log to bring up the log file that this installation is currently writing its notes to as it goes through the process. So spend some time with this log file. If you ever end up with any error messages, if you have any problems whatsoever, it will give you some really useful information about why that client is not connecting up with its Configuration Manager server. Now there's two gotchas that I can't really leave or can't really kind of let you go with without really mentioning. The first has to do with DHCP. Now when you have a DHCP server, most of us have DHCP servers that exist already in our environment, and they're probably not on our Configuration Manager server. A lot of times it's on a domain controller. A few of us may have a separate DHCP server, and on that DHCP server we'll have one or more zones that are set up. If you intend on using DHCP and Pixie, one of the things you may have to do, and this is not necessarily required, but it can be a good idea, is to actually set up a couple of scope options that will ensure that any clients talking to that DHCP server will get the right configuration to end up finding the your Pixie service. Down here under scope options, for the one scope that I have, you'll notice I have the usual scope options here, but I also have these other two here called boot server host name and boot file name. And these two correspond with the IP address of the Configuration Manager server and also the file that's located on that Configuration Manager server that's used for bootstrapping up the client. I can find that actually if I go here under Start and Computer and the Remote Install folder here, and actually not in this server, over here on the Config Manager server, Computer C Remote Install, and then SMS Boot. Subfolders of these for each processor architecture. In this case, I'm looking at x64, and there's that wdsnbp.com bootstrapper file that I'll need. So pay attention to that here when it comes to DHCP, because if you don't have this, occasionally your DHCP handoff over to your Pixie server doesn't happen correctly, and you end up getting some very strange errors. The other major error that you can receive as you're kind of poking through here can happen when you haven't actually uploaded both your x86 and your x64 boot images to your distribution point. If I take a look up here at the boot images that I have, well, I have these two boot images, one for each processor architecture. And it's actually not very commonly known that no matter which architecture you tend to focus on, both of these boot images actually have to be on your distribution point for the entire process to succeed. If you don't get it, you give it a very wild, or very weird error that's very hard to track down. So make sure that both of those are correctly and available and on your distribution points, or you're going to end up getting that problem. Now this capture process that we've got over here in the other computer is going to take a really long period of time. It can take upwards of an hour to go through the entire process of installing Windows and then recapturing it back up to your server. You'll know that whenever you're done because this installation progress bar is actually no longer there. But what I've done actually sort of in the background is already go through this process of building an OS image and then capturing it back to this computer so that you can get a look at what the result is after this entire process is complete. Let's assume that I've allowed that entire process to finish and the capture process is complete. If you recall, when we were identifying where we were going to store that image file, that WIM file, after it was complete, we're actually storing that file here on the C drive in the source files location and in this folder called W7SP1 Golden Image. There is that W7SP1-golden.wim file. So this is now the new file that you can end up deploying out to various computers out on your network if you create another task sequence. Wow, we are really, really, really far in this nugget. This nugget has gone on an extremely long period of time, but primarily because there's a lot of steps that are required even to just get to the point where we can begin deploying Windows out to the different machines on our network. So there's one final step left, and that's actually to deploy Windows. The whole reason that we've gone all the way up to this point. So let's go back in here to Configuration Manager and complete this last step in the process. That's done here under Task Sequences. Recall that our first task sequence we created was a build and capture task sequence. The one that we need to create to actually deploy that image is called an install an existing image package task sequence. Very wordy. Click Next. And we're going to have a similar series of questions that we have to ask to deploy out Windows 7. Let's deploy Windows 7 SP1, the golden image. The boot image that we're going to use in this case is once again our 64-bit boot image. We need to install Windows, and so the image package we need to use is, oops, wait a minute. We actually haven't done anything with that WIM file. See, as you can see, there's a lot of steps that are required to get us this far. Now, if you recall, what this image file is that exists currently on the Config Manager server is the original one right off the DVD. In order for us to be able to make use of this operating system image, we have to import in that operating system image here. If I right-click here and choose Add Operating System Image, I can point myself to that golden image, which is located here in the place we looked at just a second ago. Choose Next. I'm going to give this a Windows 7 Enterprise SP1-Golden, just to identify that it's the golden image. Choose Next again, and then Close. Finally, back here under Task Sequences, one more time, we go back to install Windows 7 Service Pack 1 Golden Image. The boot image is once again the 64-bit image. The image package that we need is now our golden image package, and whatever image that we want to deploy from that package. If you recall, there are ways that you can merge multiple images into one WIM file. Do we want to partition and format the target computer before installing the operating system, or install a product key, or deal with server licensing mode? Do we want to use the usual administrator password, or do we want to not actually have the administrator account enabled? Do we want to configure the network? In this case, we're going to actually join a domain. And our domain in this case is company.pri, and I can actually send this computer to the correct OU that makes sense inside of this domain. I need to give it an account that has the permission to join the domain, and the account I'll use here is my SMS client install account because that has the proper permissions to be able to accomplish the task. Type in the password, hopefully correctly. Choose OK. Next again. Again, here's the location where we actually install the Configuration Manager client. That will be the Config Manager client package, just like before, with those installation properties. Now we have this new screen that appears that relates to state migration. As I mentioned before, the same installation package that we would use from, say, a Pixie boot could also potentially be used in a refresh scenario. And this is actually relatively cool because when I deploy this task sequence out to the computers in my environment, I can deploy it in such a way so that the user state information gets sucked off of the computer before that machine gets rebuilt. I can also configure this task sequence so it becomes an optional component that the users can choose when they want to refresh their own computer. Now, if you recall, in an environment where users can select whatever applications they want from that application catalog, this becomes a really useful tool for eliminating a lot of the big troubleshooting problems that you would have in your environment. You think about it. If a person has a problem with their computer and you don't really feel like troubleshooting it, you can tell them to just simply rebuild their computer and get all the applications back that they need. You'll see here I want to capture those user settings and store them, well, via the USMT package that we created earlier. There's that USMT package. I want to save those user settings on a state migration point. I want to capture the network settings and also those Microsoft Windows settings as well. I want to include the software updates that are relevant for this computer. Here's all software updates. I also want to install any applications that are available. So are there any base applications like Microsoft Office, or in our case WinZip, that we want to make sure are absolutely on that core image right as the user gets it? So with that, choose Next again and close, and we now have another task sequence that we can use for deploying this out to the computers in our environment. Still not done yet. Told you this is going to take a while. The last step here, well, two steps. First, obviously, is to distribute the content. I've got to get that content up on the distribution point so that, well, it is available when those clients come calling for their refresh. Choose Next, and Next again to complete that process. That process will happen again in the background. Lastly, I need to go and actually deploy this image out to a series of computers. Now here's where you can get really, really cool with how you deploy this out. Here's the task sequence we're going to deploy. The collection we would deploy it to is going to be the all Windows 7 x64 desktops collection. Now before you think, well, wait a minute, I don't want to go and refresh all the computers by sending out some kind of mandatory advertisement. That's not actually what we're attempting to do here. Rather than make this a required deployment, why not make this an available deployment that allows us to make this an option that users from their application catalog can choose to do at any point that they feel necessary. I'm going to make this available. Choose Next. Set up the schedule when this deployment is available. Then choose Next again. Show the task sequence process because it's nice for the users when they can actually see what's going on and they know that it's not really time yet to work with their machine. Do I want to allow software installation and system restart outside of the maintenance window? I may. Choose Next again. I'll skip through the alerts. I'll skip through the distribution options here because I don't necessarily need to worry about them at this point. And now I've completed the configuration of this deployment. So, whew, man, how far are we? What is this, over an hour here at this point? If it's not, well, this is a pretty extensive process. But as you can imagine, the whole notion of this process is that if you take the effort and put forth all the effort in the front end, So put forth all of the work in designing all of these different layers here at the front end of the process. At the tail end of the process, what you get is what is essentially complete and total automation for deploying Windows around in your environment. Not only in the brand new scenario where a user may boot up a brand new computer and it just adds itself into the Windows domain, but also the refresh situation where a user has an existing machine and needs to actually refresh that computer. So at some point, as soon as the client and user policy get downloaded here to this other computer, that task sequence will be made available here under System Center and Software Center up here in the application catalog, where users can actually make the choice to actually refresh their computer even without you needing to be there. So this whole process, again, really exciting process and a very useful process for taking a lot of the scut work of Windows deployment really out of your hands. At the end of the day, because you've moved away from the monolithic approach to Windows deployment and to that layered approach, you can then go back and make small manipulations to the image that you're deploying out to your users by just simply adjusting those configurations across each of the different layers as they may be. Applications and user state data and configurations and drivers. So what have we talked about in this nugget? We have talked about the entire process that you have to go through in order to deploy an operating system. We talked about how that process is, well, it's really a wrapper for Windows deployment services and also the Microsoft Deployment Toolkit. And how the Config Manager and the Config Manager client provides something there. It provides an endpoint where you can actually facilitate either zero-touch deployment or user-driven deployment here in this situation. I showed you some background information here, and specifically a little ebook that I put together that'll give you the basic foundations that are necessary for you to be very experienced with this sort of operating system deployment. And then we went through the extremely detailed interaction portion where we prepared Config Manager, we captured an OS image, and then we also completed the process by deploying out that OS image. Best of luck to you in your OS deployment, and I'm very excited to say I hope this has been informative for you, and I'd like to thank you for viewing.